Yes, I'm happy to present you another project of our office, the Zwhatt timber high-rise in Regensdorf. It's a housing high-rise we are building right now. It's under construction right now and will be finished next year in springtime. The high-rise is located in Regensdorf. This is a village in the northern part of Zürich. It's a village with 3 different parts, and there at the moment there happens a big urban development in this northern area of the train station. At the moment it's an industrial area right there between these 2 woods you see on the plan, the Hardhölzli and the Schlatt woods, and there will be built a new promenade park, and in the center of this development there is the Zwhatt area. These are 2 construction fields with which our client, the Pensimo, is now developing and building different houses there. This is a sketch of Peter Merkley, who invented the master plan of these 2 building fields. On the left-hand side, H1 building field, and on the right-hand side, the building field G. It is the idea to build a new center there with a free space in the middle, and the 2 high-rises, other housings on the left-hand side and on the right-hand side. Also commercial space. We have on the right-hand side a road that leads to Zurich with a lot of traffic and a lot of noise there. And the commercial building kind of protects the area from the noise of the traffic. This is another drawing of this situation with the 2 high-rise. We also have 2 small pavilions with communal usage. In the middle, the central place, and the lower buildings with residential houses. Also, this project we won in a competition 2019, and the questions about climate and sustainability also were very important there. I show you some graphics about the Swiss numbers about greenhouse gas emissions in Switzerland. Maybe here it will be the same. That shows that buildings have a very big sector. About 24% of the emissions is made by buildings, and on the right-hand side, where you see the embodied emissions, we see that in primary structure there is also a big part of the emissions which are CO2 emissions in the structure, and that made us focus on the structure. And from the beginning in the competition, we had the idea that we would like to invent a timber high-rise. And this shows, it compares our solution, the timber or the hybrid high-rise, to a conventional concrete high-rise. And we see that we can save about 25% of CO2 emissions in the structure. And another big thing is that in the wooden structure there is stored another big number of CO2. About 1,500 tons of CO2 we can store in the wood. Of course, later, if the building somewhere will be built back, the emission will come. But at the moment, this is a positive aspect of the islands. Here's the gray energy, which is stored in the materials. is an important part. Energy flow, heating, mobility, what needs energy through the operation of the building, but also energy production that is important, and where we found a solution for our building. So when we focused on the On the structure, we, as I said, we tried to find a timber solution, but really fast we found out that it has to be kind of hybrid system. Here you can see the base, the 3 base floors, still in concrete. We invented this kind of table construction where the timber part with the narrow grid of the timber skeleton stands on, and with this table construction we could build a kind of arcade situation around the building, and in that sense we could open the building to the city, to the open space in ground floor, and made this connection. And on top there is the timber grid with the apartments in the building. Here you see the whole structure in a model. Again, the 3 base doors in concrete with the arcade situation, with this concrete beam. It's a pre-tensioned beam that catches up the forces from the timber skeleton on top. Also, some concrete walls are in this floor. We have 3 floors in the base with commercial usage, and then 21 floors with the apartments on top. On the left-hand side, you see how it works. Again, with this table construction, also the core is in concrete. It's an important part for the horizontal stabilization of the building, and timber columns and hybrid floor slabs in the wooden part. This is a detailed drawing of the floor slab system. As I said, it's a hybrid system with timber frame combined with a thin concrete plate, about 12 centimeters concrete plate, and the beams are about 30 centimeters, which are prefabricated and constructed on site. On the right-hand side, there is an important detail of the connection of the columns together with the floor slab elements, which is made with a metal part, which is connected together on site, on the construction site. We use Swiss wood for this timber construction. Beech wood, it's a local wood, and it's not very common to use beech wood as a construction material. But we worked with the Farbuswerk in Switzerland. They invented a product made of beech wood by 40 by 40 millimeter bars, which are glued or laminated together, and they can build these big beams with the beech wood, which is a very hard wood and very resilient structural timber. Also very nice to look at. And with this material, we constructed the whole wooden timber part of the building, the columns, and also the beams. Excuse me. For the structure. Here's some pictures of the facilities of the Farbuswerke. This is a picture of the facilities of Erne Werke in the timber construction company. They produce the prefabricated floor slabs, the wooden beams combined with the concrete plate, and this is how they come to the construction site. You see also transportation of these elements is important, so it had an influence to the measure of the elements. So it's maximum 3.4 meters wide, that it can be transported on streets without a special permission. Another picture of the construction site. Excuse me. The prefabrication was an advantage for a very fast construction on site. So the company used 1 day for installing the facade elements you see, and the columns, and 2 other days for installing all the floor slab elements. So in 3 days the wooden part is installed, and then they use another 3 days for the concrete core, the staircase and the elevator part with the in situ concrete. So about 1 week, 6 days for one whole floor. Another advantage is in this construction that you have with every floor, you have kind of dry situation, a temporary roof with the floor slabs, also a closed facade, and that allows you to already start with the interior building the walls inside or technical things. So you are very fast in building. Here I can show you some about the program of the house and the ground floor plan. You see again the arcade situation, the open space to the city. We have the entrance hall in the northern part, post office, bistro, the ramps to the underground spaces for storage or a bicycle room for the inhabitants. This is a picture of the rendering of the entrance hall, still the concrete part of the building in the base. We show the concrete as a visible material in this red color. We were thinking about redwoods, and that leads to all the red color in the building. Then the first and second floor is also commercial space, office space. And there we invented or we tried to find a massive facade, and it's now planned with also rammed earth. Here, this is a picture of the production of rammed earth elements, also prefabricated, and will be installed on site. We very much like this vertical structure of the formwork combined with the horizontal structure of the ramming process, and this will build the facade of the base part of the building, combined with the concrete of the table construction. And this is the first floor with apartments, 4 and 1 room apartments. You still see some concrete walls, which are they belong to this table construction. It's the only floor we have concrete walls in the apartments. Here, rendering of the corridor situation. You still feel the concrete of the staircase core and elevator situation. And then floor typology with 2 and 3.5 room apartments. These are 8 apartments per floor. In total, we built 156 apartments in this building. And then rendering of the inside, where we can see the wooden structure in the flats, and we feel the material combined with the concrete of the floor slab elements. Also on the floor, on the ground, in some apartments we use the concrete or unhibrid floor. Some of them also have wooden floors, and we like to show directly the structure. Also the sprinklers installation we need, because of fire regulations, the wooden material. In a high rise we only can show in combination with the sprinkler. And yeah, we like this installative motive in the building. Another floor typology. We have about 20 different types of apartments. Every apartment has a balcony loggia situation, but the position of the loggia is changing sometimes, and so we have a big variety of different flats in the building. Yeah, from 1-room apartments till 5-room apartments. Another picture where we can see how the structure appears in the rooms. We also try to find an answer of this architectural language in interior design, like the kitchen, for example. Another floor typology. Another picture of the room. Ventilation is a kind of low-tech system with with some parts in the windows which let fresh air in, and the mechanical ventilation is only at the bathrooms. Leads over the roof where a thermal exchange brings back the energy to the water heating of the building. Then in the middle of the building we have this communal space combined with washing rooms, and this is a room for the inhabitants. They can use it for birthday parties or things like that, and it's kind of the heart of the building where everyone comes together. In this communal space, we also try to find another solution for floors. We also use rammed earth for the floor. At the moment, it's still a little expensive, so we cannot use this in every apartment. But the client was okay with using rammed earth as a floor in this communal space. And these are some examples. For this room, it's 2-story high, so a very nice situation in the middle of the building. This is the section through the high-rise. You can see again we have 2 underground floors with storage and bicycle. Then we have the through base doors with the arcade situation with commercial space, and then the 21 floors with apartments, and in the middle you see the communal space. Also the neighbor building, which is setting back the other tower from the other building field. Section in other direction, you see also the pavilion, the neighbor building, the entrance situation. To the facade, it's not possible to use wood in the facade in a high-rise due to fire aspects. So we were thinking in the competition, we were thinking about the metal facade, which is still it is, combined with PV elements. This is an early stage of the design where the PV elements were vertical integrated in the facade. During the progress, we invented this idea with horizontal PV elements like little roofs for a different appearance, very technical and fine. This is a picture of the mock-up we built, and this horizontal kind of PV elements also helps to protect also produces some shading of the facade and helps to protect from overheating. We also like the appearance in contrast to the inner structure in wood, so a very fine metal facade with these technical aspects. And below you see the massive concrete table, the massive rammed earth facade, And yeah, we like this tension between different materials in appearance of the building. This is another view from the inside. So also the PV panels you can see from the inside. Maybe it helps the people who are a little bit scared about the height. So you have here like an outer part of the facade, a filter between the inside and outside. And the horizontal position of the PV panels allowed us to generate more surface of the panels. It's about 40% more surface we generated with this position of the PV panels, and also the production of the PV energy is higher in that sense. There was also the fire aspect in the PV panel, so it's not an unburnable material. It's made out of two glass shields, and together with the authorities, we have to prove that the fire, in case of fire, it's not spreading about all over the facade. Due to the PV panels, the cells and the foil in between the two glasses is burnable material, but a fire would stop after a while, so a fire cannot spread out in the facade, which is very important to get the permission to build something like this. So yeah, that's the movie of the test we did for this PV panel. Okay. Yeah, this is finished with fire. Thank you very much.